Welcome to part 3 of Competency 10. In Competency 10, the expectation of the teacher is that you can solve problems using differential and integral calculus. That point I didn't make in the first two videos. I actually had it incorrect from the prior or the next competency. I apologize for that. But anyway, I did have the percentage correct. Okay. And in this particular video, we will answer questions relating to derivatives and the chain rule. Number 1, if y equals 7x minus 12, what is the simplified expression for the first derivative? As you probably already know, that is the notation for the first derivative. Okay, so what happens here? Well, the negative 12 becomes 0, and then we just, using the chain rule, we simply have 7, okay? So that will be option A. So my thought is here is if you aren't familiar with the chain rule, you need to stop the video and go find other videos out on the internet, which at the end of all my videos, I have a suggestion of one particular YouTube channel that has everything you need. You just type it in, search that channel, and you will find a very excellent detailed video. I've checked and double checked. That is probably my favorite go-to place, okay? So for the rest of these videos, you will hear me say first derivative chain rule, second derivative chain rule, and I'll go through that process, okay? Anyway, for number 2, if y equals negative x to the fourth plus 5x to the third plus x, what is the simplified expression for the first derivative? Okay, we do this term by term. The first term becomes negative 4x. Okay, so any of these that don't have that, mark them out. So now we're down to 2. And the second one is 15x to the second. So I will go ahead and pull that out and do a recap of the chain rule, okay? But just for this term, I'm not going to harp on it. This is something we should have had well, we all had it, either in high school if you took calculus or in Cal 1 in college. So this is pretty basic stuff, okay? So what do we do? Well, I'm going to give you this first. Okay. So essentially, we are bringing down that 3. So that means we have 3 times the 5. You leave your x. Oh, I'm not sure what kind of 5 that is. Okay, I'll clean this up. That's a little better. Okay, then we take the 3 minus 1, and that is going to equal 2. So now to simplify the whole thing, we have 15x to the second power. Okay, so I can already go to my options and see that they forgot to subtract 1 from the exponent 3. So A is incorrect. Now, if we continue out to the next term, okay, then I'm going to draw a line here. So what do we have here? We have 1x to the first. So what is that going to be? Well, 1 times 1, x to the 1 minus 1 equals 0. Well, you know anything to the 0 power becomes 1. So what are we really ending up here? We're ending up with 1 times 1 times 1. And that's just 1. So that's how we derived all of this, okay? Option D is correct. All right, so if you notice, I haven't even touched my calculator. For a lot of parts, many parts of this section, I will not be using the calculator, okay? So let's go to Now, for this one, I will. For these two, yes, we'll use our calculator. You never know what they're going to ask you. Okay, so number 3, if y equals, okay, here's our function. What is the value of the first derivative at x equals 2? Yes, for this, definitely. So let's go ahead and put that in. All right, so let's see here. We have, all right, let's do y equals. And yeah, I'm going to put everything in parentheses correctly. Oh, let's clear that out. Now, parentheses, we have x to the second minus 2x plus 9, close my parentheses, open more parentheses, and then we have 6x plus the 3, close my parentheses. Now, let's push graph. Ooh, very weird graph. I mean, we don't see everything. It does not matter. Okay. On the graph, this is what we do. Say second trace, which we're going for the blue up on top. It's the calc. And we need number 6. So push 6. Now, we're on the screen that we need. And you know this because of how the display looks. Look. How it's giving you your function up above. We know it's the correct function. So now we want the x equals 2. So simply enter 2. And see, it pops up and it gives us what we need. And push enter. And you will see right up above this the notation they use in, well, if I can, okay, here we go. This notation right here, your dy dx, that means first derivative. And notice out beside it, it has 84. Now, it will have 0.00000 and then some number way out there, okay? Disregard all that. Our value we're looking for is the 84, okay? Now, if you went through the process, found that a first derivative, and you substitute in the 2, yes, you will get what you need. I don't waste my time with it. When they ask for a specific value point of x, I'm done. Okay. And I know exactly what to do. All right. Same thing here. We put it in the calculator exactly like we see it for number 4. Here's our function. What is the value of the first derivative at x equals minus 1? Absolutely excellent. Okay, so I'm going to back out. I'm going to go to my y equals. I'm going to clear the whole thing. And then I'm going to put in each rational term separately. Okay, so I do that by doing window, alpha, window, arrow over, and I need the number 1. So I push enter. Okay, so then I have 7. I arrow down. And then I have x squared. I have to arrow over to put in my subtraction and then repeat the process of alpha, window, arrow over. Go ahead and push enter because I want number 1. And then I have 5, arrow down, 2x, caret up to the 6. Okay, I'm going to arrow over so you see it all. Okay, there we go. All right. Now, I will graph that. Okay. Interesting graph. All right. So while I'm there, I say second. I go to trace, which is my calc. I need number 6 again. And then just push in, just press -1. And that now you see what you need right here. Push enter. And there's our answer. Well, it's -1 again. And like I said, you have that 000 and then some numbers after. That's like a estimation error. Don't worry about it. This option D is what we're looking for. Okay. All right. Let's move on. Number 5. If y equals x minus 3 over x squared plus x minus 2, what is the simplified expression for the first derivative? Okay. So there's something that I always remember when I'm doing these, when I see a rational. I know that this denominator must be squared. I also know that I will have a situation where I subtract, and then I know that the numerator should be prime first times the denominator as is. Then that is subtracted. We subtract from that the numerator as is times the denominator prime, which means first derivative. When I'm saying prime, you see prime notation. That is saying the first derivative. Okay? All right, now, all right. What we need to do is look at our A, B, C, D option. Okay? That means if you're looking at what I've written here, the denominator squared, A and B are out of the running. They're not going to work. Okay? So what we really need to look at then is the denominator. What should that be in the end? Okay, so let's start writing this out. So we know that y prime should equal. Okay, so x squared plus x minus 2 squared. Okay, and now my numerator, I'm going to follow this pattern. Okay, so the numerator is prime with the first derivative. That just ends up being 1. Okay, so 1 times what? The denominator as is. Okay, yeah, I don't need to write the 1. But I am. Okay, so that is x squared plus x minus 2. And we will subtract, okay? Now we need the numerator as is. Okay, so that will be x minus 3 all times the denominator prime with first derivative. So that's 2x plus 1. Okay, now we need to clean that up. Let's rewrite that equals. Okay. X squared plus x minus 2 squared. Okay, so we have x squared plus x minus 2 as is. Now we need to subtract all this, all right? So we need to have minus, I see 2x squared minus 5x minus 3. Okay, now let's take a look at that. Normally, if I was going to turn this in, I would rewrite all that. But we're trying to pass a test. So see that negative, I will distribute that in. I'll erase my parentheses and then turn this negative to a positive and this negative to a positive. Now we can rewrite to finalize, okay? So we know not to mess with our denominator, okay? Squared, that is. Okay, he's fine the way he is. Check. Now, let's deal with our numerator. I'll change colors, and I need to add like terms. So a negative 2x squared becomes negative x squared. Okay, well, both C and D have that. Now, combine our x terms. Well, a plus 5, and a plus 1 become plus 6. So that and that are done. Well, that's the same. It all goes down to the plus 1 or minus 1. Well, negative 2 plus 3 is plus 1. And that gets us option C, which is correct. Okay. All right, now let's go to number 6. Notice again, didn't use the calculator. Sometimes it isn't going to happen. We will not use a calculator. Now, if you are multiplying large numbers as you are using the chain rule, yes, don't do it by hand. Don't even try. Just pop it in the calculator to maintain your accuracy. Okay, now for this expression, it says if y equals, and there is your function, what is the simplified expression for the first derivative? Okay, we are using the chain rule, so we're going outside in. So what does that give us? Y prime equals, okay, that is 3, and keep the 3x squared minus, oh my hand, you have to be able to read it, right? Okay, let's see here. Minus 7. That all stays the same. But we brought down the 3, so we have to subtract 1 from our exponent, which gives us 2. Now, we multiply the derivative of the inside. Okay, we multiplied that to what we have. So the derivative of 3x squared will be 6x to the first, and negative 7 just becomes 0. So we have 6x to the first, okay? So it just becomes 6x. Right now, we can multiply some things together, all right? Well, we can, let's see here, the 3 and the 6x can be put together. So we can multiply 3 times 6. That would be 18, okay? So what do we really have? 3 times 6x, and then do we just leave the 3x squared minus 7x squared alone? Okay, now we can come over to our option, our ABCD options, and I see some things that are just flat wrong. This exponent is incorrect, and this exponent are incorrect. So we get rid of B and D. Now we're down to A and C. Well, obviously, A is the option because 3 times 6 is 18. And what option C is trying to do is you may have skipped a step. You may have not properly brought down the 3 or not multiplied it in the end, whatever, or seen it, or just not used it. Anyway, the correct option is A. Okay, all right, let's go to number 7. Number 7, if y equals x times ln x, what is the simplified expression for the first derivative? Okay, there's a couple of rules being used here. First rule is that when you see these things, that actually we have two things being multiplied together. We have a variable times a logarithm, okay? So how do we deal with that? This is what we do. Okay, whoops, sorry about that. Well, the x, we're going to call that function f, and the ln x is function g, okay? And this is how you'll be taught. Leave f as is times g first derivative plus, okay? Then we have f first derivative times g as is, okay? So that means for y prime, we have x, multiply that by, well, this is the next rule. The first derivative of ln x is 1 over x. Now, you may have noticed at the first of the video, this particular video, that was in the introductory screen. As I talked a little more, it was up there. So you may want to go back and take a screenshot of that or go to your notes and find that. But this is a very popular. The log ln x, or 1 over x, one way or the other, you will see this, okay? All right, let's move on. We have plus, now the first derivative of x is 1, okay? And we're multiplying that times g as is, which is 1x. Cleaning all that up. Well, x times 1 over x, that's going to equal 1. And we add that to, well, 1 times anything is the anything. So that's ln x, which would be option B. Okay? Like I said, if you're a little rusty on these, of course, we're going to explain them, talk about them while we use them, but go find yourself some notes, good videos, like I've mentioned more than once. There is a YouTube channel in my resources at the end of every video that you may want to use. Okay. All right. So let's go to number 8. If y equals, okay, we have a multiplied function again. Okay. What is the simplified expression for the first derivative? Okay. So we'll apply the rule we had before, and that was f is simply written down as is. Remember, this is our f, this is our g, okay? So y prime equals 9x. Now that is all times the derivative of g. Okay, now that's going to be a little tricky because the e exponent is unique, okay? So what we do is we will take the derivative because we're inside out, okay? All right. And e, the derivative of e to the x is e to the x, okay? So what we're doing is write down as is e 7x squared minus the 1, okay? But then we multiply to that the derivative, here I'll circle it, the derivative of the exponent, okay? Remember, it's the outside in. Well, e doesn't have necessarily a derivative, so we just write it down. Then we go to the exponent, and then we take that derivative. Okay, well, the derivative of 7x squared minus 1 is 14x. Okay, so that's just the 14x. All right, now what do we do? Okay, uh, we add that to, I'm sorry, I had a moment, I had to look at it. Okay, now we add to the other one. Okay, so we have to take the prime of f and leave g as is. Well, 9x prime, or the first derivative, is simply 9. So then we have 9 times g as is. So that's e to the 7x squared minus the 1. Okay, we've got a little bit of cleaning up to do. So let me get rid of this so we can see it better. Okay? Okay. We need to bring some like terms together and realize that we need to pull out what's the same on each side of our plus. Okay? So what I mean is anything that is the same on this side and this side of our plus sign, we can pull them out. Well, I see this entire phrase here being hidden over here. You see that? Because they're multiplied together, we can pull them out. So we are simplifying. Okay, we're cleaning it up. So pull out your 9e 7x squared minus 1. Okay, pull that whole thing out. Now what's left? Okay, don't forget that we still have this plus in here. We pulled it out from the entire thing. Okay? Right? So if I pull, let's look at the first part. Let's look at what we have before the plus. Well, I have an x left, and then I have a 14x. Okay? Right. I have the x here and the 14x. Remember, everything is multiplied together in one big term before the plus. So I rewrite that as 14x squared. Okay? And then I leave my plus. Well, what happened when I pulled out the 9e to the x squared minus 1? Well, that just left a number 1. Okay? If you've done several of these, you get used to what it should look like and how to do them. If you're not sure what I did, rewrite it, maybe write it differently and do it for yourself again. I've done so many of these that I just kind of see it. Okay, now let's look at our ABCD option. Well, there's some that just won't work at all. Let's see. A. I don't like A because they pulled out an X that was not existent in this second term here. So I'm not feeling A. B, look at what they gave us here. And they pulled out a 14. No, you can't do that. You can only pull out and put in front here what you have on both sides of your plus sign. So you're looking at your plus here. So no, I don't like that. Okay, so let's get rid of that. All right. And C, no. They didn't pull everything out. They left some things in that they shouldn't have. So the only option, hopefully D is it. And yes, I agree with the term being pulled out. And then I agree with where they left their plus. Okay. So that would have to be option D. Okay. All right. And that is the last question in this video. I hope I was helpful and that you like our videos. And also, don't forget, if you haven't subscribed, if you have subscribed, please share with other people and like us certain videos that are your favorites. It helps us judge what we're doing. And once again, happy testing.